Stop guessing your learning rate. A static value might get you stuck in local minima, but intelligent scheduling can dramatically improve convergence and boost final performance significantly. Learning rate determines how quickly a model learns from data by controlling the size of weight updates. A fixed rate often fails because it cannot adapt to the changing landscape of the loss function as training progresses. Schedulers refer to the deliberate modification of this global base learning rate over the course of training. The goal is not merely to make the learning rate smaller, but to optimize learning dynamics for better results. A low static rate leads to slow convergence and increased computation time, whereas a high rate causes instability. Dynamic schedules allow the model to take large steps initially for fast progress and smaller steps later for fine-tuning. Experiments on physics-informed neural networks and image classification demonstrate that these strategies accelerate training and improve stability. The choice of scheduler often matters as much as the model architecture itself. By intelligently adjusting parameters throughout the process, these schedulers help prevent common optimization pitfalls and reduce training time. This is crucial for complex applications like robotics and machine learning. Ultimately, the right schedule balances speed and accuracy, ensuring the model finds the global optimum rather than getting lost. This simple adjustment is a key driver for modern deep learning success. Understanding these dynamics transforms how you build models. What scheduler do you use in your projects? Let us know in the comments for more deep dives into machine learning techniques.